We're on Unit 2, Notes 5, Derivative of a Function's Inverse. So this is my 5th video that I've done this afternoon. So if I start to mess up my words a little bit, you guys can understand and cut me a little slack. Alright, so derivative of a function's inverse. Let's talk about this because it's been probably a little while since you've thought about inverse functions. So first of all, if f and g are inverses, we know, first of all, we know that they have corresponding points, okay? I like to use, and I should have kept, I probably do have that. I do have it. I like to use the example of e to the x and natural log x because those two are inverses of each other. So here's a graph. This is from my notes from exponential functions. The graph of e to the x and the graph of ln of x, they have symmetry with respect to the line y equals x. Okay, so that's always true. They have corresponding points. So the point E1 is on ln of x. The point 1e is on e to the x, y equals e to the x. The point 10 is on y equals ln x. The point 01 is on y equals e to the x. So those are called corresponding points. Okay, so if AB is on F, then BA must be on G. Okay? So corresponding points. All right? So that's one thing about inverse functions. Another thing about inverse functions is this. Notation. Let's talk for a second about notation. If f and g are inverses, then I'm saying that g of x is the inverse of f, like that. And f of x is the inverse of g, like that. Okay? This notation, this -1 little notation for an inverse, that sometimes kids get a little confused on that. Now, and I know why, because it looks like it's an exponent, doesn't it? It totally looks like it's an exponent. But it's not. It's notation for an inverse. Now, x to the -1, that is an exponent. So this would be 1 over x. 5 to the -1 is 1 over 5. -3 squared to the -1 is 1 over -3 squared. Okay? So this, when you see a -1 on a variable or a number, or an expression involving just variables and numbers, this -1 means it's the reciprocal of it. So 1 over whatever's inside there. Okay? It's the reciprocal. So that means it's an exponent. But if this is not a variable or a number, in other words, if it's a function, then it does not mean reciprocal. If it's a function, and we have that -1, that does not mean it's not 1 over that function. Okay? What it means is it's the inverse of that function. It's just a notation. Okay? So what about sine inverse of x? That does not mean 1 over sine x. It's not true. This means the inverse of sine x, okay, also called arcsine x, okay. All right, so a little word about notation. So a function set -1, it means inverse, not 1 over, okay. All right, so corresponding points, notation, something that you may or may not remember from last year. If f and g are inverses, then f of g of x is equal to x, and g of f of x is equal to x. That's just true. Okay? All right. So just a little bit of a thinking on that. Let's start with this. Let's say that f and g are inverses, so I'm telling you that g is the inverse of f, and f is the inverse of g. So I know that f of g of x is equal to x. It has to be true if they are inverses. All right? I'm going to come in here. I'm going to take the derivative of both sides. I'm trying to find well, I'm not going to tell you what I'm going to find yet. Okay? I want to find g prime. But anyway, it's all right. Okay. I'm going to take the derivative of both sides with respect to x. So derivative of both sides with respect to x. Okay. I need you to remember how you take the derivative of this composition function. Okay. It would be like taking the derivative of f of x cubed. What's that derivative? Well, it would be f prime of x cubed times 3x squared. That's what that would be. So the derivative of f of g of x is f prime of g of x, little chain rule, times the derivative of the inside. Okay? And that would equal the derivative with respect to x of x, 1. So I'm going to solve this for g prime of x. That's what I was trying to find. 1 divided by f prime of g of x. Okay? All right. What does this mean in our problems? If AB is a point on f of x, let's say, then we know that BA must be a point on g of x, okay? So g prime at its x value, B, that's g prime at g's x value, has to equal 1 over f prime at its x value. Okay? So the derivatives are reciprocals of each other at their corresponding points. They're just reciprocals of each other. So, anyway, okay, let's look at some examples. Number 1. If f of 2 is -5 and f prime of 2 is 1/3, what is the derivative of the inverse? There's the inverse of f. The derivative of the inverse at -5. Okay? So, let's think about this. So, first of all, let's think about these corresponding points. What are the corresponding points? Well, the point on F is to -5. They gave us that. Therefore, what is the point on F inverse? Well, that must be -5 too, right? So they gave me that f prime at its x value is 1/3, and they are corresponding points, so the derivative of f inverse at its x value is just the reciprocal of 1/3, and the reciprocal of 1/3 is 3. Just the reciprocal. Okay, number 2. What if f of x is 3x cubed plus 5? I want you to find the derivative of f inverse, at 8. At 8. Okay? The derivative of f inverse at 8. Okay, let's approach it similarly to the way we approached the first one. What do I know? Well, I know that a point on f inverse has x coordinate 8. I don't know what the y coordinate is, but I know the x coordinate is 8. It has to be. Okay? So my point on f the corresponding point on f must have an y coordinate of 8. I don't know what the x coordinate is. But if I find that x coordinate, I'm going to be in really good shape. Okay? So that's where I'm going to focus on. Let's find this first. How do I find that? Well, I know that the y coordinate is 8, and I have a function. So all I have to do is set that function equal to 8 and solve it for x, and I'll have that x value. So subtract 5 from both sides, divide by 3. I'll get x cubed as 1, so x has to be a 1. So I have found that x coordinate has to be a 1. Alright? Now, if I find f prime at 1, then to get f inverse prime at 1, at 8, it's at its x value, all I'll have to do is flip this, right? So let's find f prime at 1. Well, f prime at x is 9x squared. So f prime at 1 is 9 times 1, 9. So f prime at its x value is 9. Therefore, the derivative of the inverse at its x value must be 1/9. If you find f prime, just flip it to get the derivative of that inverse. Number 3, part A. Find the derivative of h inverse at 3 given the table on the right. Okay, here's the table. Oops, x, h prime of x. 3, 7, 2, 3, negative 3 halves, 4. Okay. So we're looking for H inverse prime. And we have this. Okay. Well, I'm going to approach it the same way we've been doing. A point. Let's see what we have. All I know is that the inverse has an x-coordinate of 3. So the point on H inverse has x-coordinate 3. I don't know what the y-coordinate is. Really don't care what the y-coordinate is either. Therefore, a point on H must have y-coordinate 3. Well, if I go to my table, this is important. We always want to find that first. Okay? So if I go to my table, H has a y-coordinate of 3 when x is 7, right? So this must be a 7 from the table. Okay? H prime at 7 is what? Well, from the table, H prime of 7 is 4. Therefore, the derivative of H inverse at its x value must be 1/4. Flip that. Okay, that was part A. Part B. Write the equation of the line tangent to the graph of y equals H inverse of x when x equals 2. Okay? Well, this time I want H inverse to have a x coordinate of 2, right? So point on H inverse. X coordinate is 2, don't know what y is. But if that's true, then a point on H must have y coordinate 2. Gotta find this guy. So when y is 2, what is x on H? So when y is 2, x is 3. That must be a 3. Which means H prime at its x value, 3, is negative 3 halves. Therefore, the derivative of H inverse at its x value is the flip of that, so negative 2/3. And this point here, we need this point this time because we're finding the equation of a line. So I've got the point and I've got the slope, so I can go write the equation of the line. Y minus the y value is equal to the slope times x minus the x value. And you're done. Okay. Alright, I have one more example for you here. I have to cram it in the bottom, so I'm just going to go to another piece of scratch paper. Number 4, last example. If g of x is the inverse of f, okay? If those are inverses, and f of x is sine of 3x, restricted to x being between 0 and pi over 4. Find g prime of 1/2. G prime of 1/2. Alright. Point on G. The x coordinate is 1/2. Don't know what y is. Point on f then. They're inverses, so the y coordinate has to be a half. I don't know what the x coordinate is, but that's what I want to find. I want to find that first. Since I have an equation for f, I can set sine 3x equal to a half and find out what x is there, right? So sine of 3x, set that equal to a half. We have to solve this little trig function without a calculator. Okay. Well, sine is a half at pi over 6, right? So 3x has to be pi over 6. There are other values, but I know with this restriction, I don't have to worry about those other values. I'm pretty sure that when I solve this for x, it'll be in here. Divide both sides by 3 or multiply both sides by a third. And we'll have x is equal to pi over 18. So now I know right here this is pi over 18. Okay. Now I want to know what f prime at pi over 18 is. Well, I can get f prime of x pretty easily. What's the derivative of sine of 3x? 3 cosine of 3x. And now plug in pi over 18. And we'll have 3 cosine of 3 times pi over 18 is back to pi over 6. Cosine of pi over 6 is square root of 3 over 2. So this is 3 square root of 3 over 2. So f prime at its x value is 3 square root of 3 over 2. Therefore, g prime at its x value is the flip of this. So 2 over 3 square root of 3. Okay? Fun with inverse functions. So go try it, see what you think, bring me your questions.